and welcome back to CSC 151 Computer Applications. In this video, I'm just going to be making a couple of cool little things using loops and, and if statements and basically all the generalized stuff that we've been doing up to this point in class. So, oops, there we go. Now that I'm actually in the window, I can actually do this. So the first thing I'm going to do is I'm going to just make a program that deletes letters from a word. So let's just say my word is, I don't know, porcupine. Porcupine. And I'm going to also make a new word, and that new word is equal to nothing. Because as you can imagine, I'm going to be taking letters from this and building out the new word as it gets made in a loop. And I'm going to make something called vowels, and the vowels is literally going to be a. Actually, I should probably. I'll keep the capital P just in case. A, E, I, O, U. Don't need to worry about sometimes Y and sometimes W. Yes, sometimes W. There are a couple of Welsh words in the English language that have W as a vowel. They're very rare, though. So I'm going to say this. For letter, so letter is now a new variable name that I've declared, in word. So for the letters in the word, so each individual letter in the word, I'm going to do this. If letter dot lower, because I'm just going to assume that capital P there, might be a lower, I'll just switch it to a lowercase just in case. If lowercase lower, not in vowels. So if the letter is not in vowels, I will add it to the new word. So new word plus equal letter. So the new word, which was blank, is going to be whatever the letter is, going to be added to it. So it's going to become the P, but then, since this not in vowels part, because A, E, I, O, U, is false for that O, it should in theory skip the O, and then go over to the R, C, so on and so forth. So, and just to prove this point, I'll print out new word, just so we can see this get built in real time, so that you'll see it happen in each part of the loop. So it became the P, then PR, PRC, PRCP, PRCPN. So, yes, we successfully deleted all the vowels from the word porcupine by the end of this loop. And assuming we moved this outside of the loop, we would get this result without seeing all the incremental steps in the way. That's the first thing I'll show off. Second thing is the word scrambler. So instead of having, the word porcupine up here and then removing all its vowels, let's just randomly change all its positions of every single letter we have in it. Oh, well, I'll probably still need a new word, so let me just, because new word is going to still equal something, and currently it equals nothing. But we're going to randomly grab letters out of this, place it here, and then we're going to essentially be deleting this word one letter at a time as we add to this word one letter at a time. So I'll just say while word. So while word exists, while this still has a letter left in it somehow, I'm going to make a POS for position. And the position is going to be a random, I should probably import random then. Import random, random dot rand range, and the random range will be the length of the word. So that I have, so this is the length of the word, and then when, a couple letters are deleted, this is the length of the word, so on and so forth. So the length will constantly be changing, but I want to grab a random part of it that's not, so I don't accidentally have a 3-letter word and I somehow grab a 7. That won't help me. I'll be grabbing something that doesn't exist, like we saw in the in my little card thing where I forgot to put a comma in between two of my little pictures. Then I'll just say new word is going to be equal to itself plus the position of the word that was taken. So basically, I'm adding the random letter from that new word. So whatever number I get, if it's number 0, or if it's number 2, or if it's number 3, whatever letter I grab will now be added to this. The position will be added to it. So there we go. And then I will also have to delete. So I've added it to the word. So in theory, if I keep doing this, let me just print out new word here just to prove a point. I'm grabbing myself random letters every time. I grabbed a P, then an I, then a U, then an E, then an O, then a capital P. But I'm repeating letters at this point in time because I have successfully added letters to the new word, but I have not yet successfully shrunken down the original word. So just to prove a point here, whoop, 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 there we go. Don't delete anything you don't want to delete there, David. I need to make sure that this word eventually deletes itself. So word is going to now equal something that is not the word. Now, I might be able to get away with minus equals, but that might be interesting to see how that works. So instead what I'm going to do is I'm going to do this. Word is going to be equal to word, but specifically only the whatever stuff comes before the position plus specifically all the things after the position. Remember where we did ranges in our lists? So there's everything up to the word. There's whatever is after the word to the end. So from the start to the start of the letter, from the end of the letter to the end. So basically, we're cutting out everything that's not exactly the letter. So now what you'll wind up seeing is if we were to, print out the new word in sequence, we'll see that it stops once we got to the end of where porcupine should be, because we've been successfully deleting letters from this now by simply making a range. So right now we got the I. So this word right here, that part right there, that's everything before the I. And this part right here is everything after the I. So the word, which was right here, will become everything before and after the letter selected, effectively deleting a letter, one letter at a time, as we pick it and add it to our new word. And just to showcase outside of having all the steps, there we go, there's a version of it without the steps. There's another version without the steps, so on and so forth. And you know what, as a third thing, let's make ourselves a rock, paper, scissors game. So, I'm going to make myself a game, and we're going to say it's going to be rock, paper, scissors. So, we could do the normal, hello, welcome to rock, paper, scissors. I'm going to name this P1 for player 1 equals input. Actually, let me make this an integer input. Input. Type a number. And I'll make a couple /n. 1 equals rock /n. 2 equals paper /n. 3 equals scissors /n. Make another /n and I'll say your choice. So if I did that correctly, there we go. Oh, had a space after the N. There we go. So your choice, there we go. So I know that's working. So, and then I'll also have player 2. Player 2, which is our computer, will be equal to a random.randInt, and I'll make it 1 to 3 as well. So there we go. Now, here we have ourselves all our logic. We have ourselves our number and their number. So let's make ourselves a loop. So yeah, I'll do this. While true, I'll do this. I'll do that. I'll just do that. There we go. While true. Actually, no. I'll just use an if statement. I won't do a loop on this one. I did loops in the previous two. So if, P1 equals 1 and P2 equals 1, well, that means we wind up with a draw. Draw, right? Well, let me put that in quotes. Print draw. Actually, no. I'm not even going to use an and. I'll do this. I'll do this. So if P1 hit 1, I'll print this, and I'll say print player selected rock. I'll make another if statement right here. I'll make an if statement inside an if statement. If P2 computer selected rock, print draw. There we go. And I'll just copy this. If they selected 2, player selected scissors. Oh, rock, no, actually paper. They selected paper, which means I lost. And I'll do this. If player selected 3, computer selected scissors, and I'll put the win. Now then, I'll just copy this, make this an elif, because this elif right here is going to attach to this if. These elifs are attached to this if. So if I selected 2, player selected paper, and if I had paper, we had rock, and the computer picks rock, that means we win. If they picked paper, that means that's a draw. And if they picked scissors, that means we lost. And let me just do this one more time. And if we selected 3, that means we selected scissors. Player selected rock, they pick rock, we pick scissors, that means we lose. They pick paper, that means we win, because scissors cuts paper. And if they pick scissors, that means we have a draw. In theory, this should get every single possible 9 outcomes I could possibly have in rock, paper, scissors. Let's play this. My choice is 3. Player selected scissors, computer selected scissors. Let's try this again. I'll pick 2. Whoop, whoop, whoop. I'll pick 2. There we go. You selected paper, computer selected rock, we win. So far, it looks like it works. So that's just a couple of cool little things we can do with if statements and loops. What I'm going to do in the next video is I'm going to put this all together. That's your mother. That's your mother. Don't bark at your mother. Silly dog. So anyway, in the next video, we're going to actually do the follow-along assignment. So I'm going to mix up some if statements, some loops, some and, ors. I'm going to basically do a little bit of everything. So in that video, remember to follow along, save things and whatnot. I'll see you there when you get there. Have a great day.